Hello, chemistry students. So Miss McDonald and I are here. We're going to be doing a video for you guys. So we've learned a little bit about periodic trends, and today we're going to look at reactivity of metals. We got 5 different metals we're going to be looking at. I'm going to show you those metals, and we're going to show you like the reactivity with it, and you're going to be taking notes on your sheet next to the pictures. There's pictures of each thing on your note sheet. Alright guys, so the first one I'm going to look at with you guys is lithium. So, we got our bottle of lithium here. There's a bunch of oil here. This is packed in mineral oil. And this comes from Flint. It's out in Batavia, out by me and Miss McDonald both, out in our little neck of the woods. So it talks about the hazard alerts for this one. In contact with water, releases flammable gases which may ignite spontaneously, protect from moisture, causes severe skin burns and eye damage. So that's why it's stored in the oil and everything as we go along. And I took some out and I put it on a little well plate here, and I'll try to see if you can see that. Get a point where you can see it. I might just hold it up there so you might see it better. All right, so there's a piece that's in covered with oil. That's what looks kind of oily there. I'm going to try to cut this though.
Yeah, the outside looks kind of dark.
All right, so when I cut this, so I'm actually just using a regular scoop gun. I'm trying to cut it, and it's kind of like butter right out of the fridge. So it's kind of like stiff a little bit. But what's neat about that is if you look at the inside of that thing, you see how shiny it is? Outside is all black, but the inside is nice and shiny. And isn't that a characteristic of a metal, right?
Yeah, characteristics of metal. They are shiny, they are malleable, which is exactly what you just showed us because you were able to cut that with just the blunt edge of that scopula. Yeah, so they're soft, and they're also good conductors of electricity and heat. But something that's special about the alkali metals that the lithium belongs to is that they are going to react with water. So, to show us this, Mr. Man,
Are you guys ready?
we're ready. Dump it in the water.
All right, so I got this I'm going to put on top of the water. And then I got my little piece I'm going to put in the water.
Go ahead and record your observations on your paper.
You guys should be hearing sizzling going on. Notice it's actually floating. I see. You probably see the thing kind of bouncing around a little bit, floating inside there. And it's also giving off a little bit of white smoke.
Some vapor, yeah.
Yeah, little gases coming off of that.
You can see the bubbles that are being made.
And again, the bottle talked about releases flammable gases. So it's not, there's no flammable gases here. There is a gas coming off. And yes, it's definitely making bubbles.
Yes, it is.
So that's been going for
30 seconds?
30 seconds or so. One thing we're going to do to this as well is add this chemical called phenolphthalein. This is something that, in the presence of a base, it will turn from clear to this pretty pink-purple color. And so the solution we made is basic.
Pretty.
So I can swirl that in a little bit. Anyway, we get a nice pretty color with that one.
So our metal is reacting with the water to make a new compound, which turns our indicator pink.
Yep. All right, so then the next one we're doing is sodium.
So everyone, be sure, if you need to, pause the video so that you can write down your observations next to the picture of the battery, because a lot of the batteries that we use now are made with lithium. So write down the observations, whatever you saw in the beaker. All right, what are we looking at now, Mr. Man?
All right, the next one is, I got my container here of sodium. And again, it says metal lumps packed in mineral oil, flammable, corrosive, solid, dangerous when exposed to heat or flame, dangerous by reaction with moist air, water, spontaneously flammable. So again, a lot of the same warnings we had from before. This one's a weird looking metal though. So if you take a look at that one, it's sort of like, it doesn't look shiny at all, and it almost looks like, I don't know, a yellow light gray rock.
Looks like rust, like it rusted
Yeah,
or
like
something,
a rusty
like
piece of something.
oxidized.
So what I'm going to do is I'm going to try to cut this like I did with the other one. And this time when I cut, this is much softer than the last one. But again, when I open it up, you should be able to see the shininess in there.
Look at that.
The inside is very, very shiny. The outside still looks kind of rusty or whatever.
Yeah.
But the inside's definitely shiny.
Huh. So remember, everybody, that sodium and lithium are in the same family, the alkali metals, and that sodium is just below lithium itself. So I want you to think about some of the differences in structure that lithium and sodium have if sodium is below lithium on the periodic table. All right, are we doing the same thing? Are we going to dump it in?
I'm ready to put it in water.
All right, let's
so
see what happens.
Got my pieces. All right, so I dumped it into water, and our pieces are floating on the surface. Notice they're actually moving much faster than the last one. The last one kind of bumped around, and we are getting gas just like we had last time.
Fizzing, bubbles.
Yep, fizzing and bubbles just like before.
Oh, but that one piece definitely dissolved pretty fast. We just have that last one that's kind of zooming around in there.
So compared to the last one, would you say this is faster or slower?
I would say that this one is faster than the lithium was.
I think so too. I think it definitely went faster than the last one.
Oh gosh, and I know you guys probably can't see it, but there's quite a lot. Oh yeah, you can see it. The little wisps of gas that are coming off of that. So there's a lot more gas that was created. And there we go, and let's see what happens. Let's see.
Same thing again, see if we can get the pretty color. So within the same family, you would expect to get similarities as well. And so the last one made a base. This one's also making a base. And again, we're getting a nice, pretty pink color there for a base.
Yep, so again, we've got the metal reacting with the water to make a new compound.
All right, that was sodium.
Yes.
All right, I'm ready for the next one.
All right, so everyone remember, pause, write your observations next to the picture of the salt shaker. Because sodium is one of the elements that makes table salt, right? Table salt is sodium chloride. So write your observations. All right, what's next?
Next one's potassium. This one also has a lot of the same warnings. It says extremely dangerous in contact with moisture and water. So kind of trying to scare us a little bit here, I think.
I think so.
All right, I'm going to take a piece out of here. And if I take a look at this piece, again, it's a weird-looking metal.
It is.
I don't want to drip on our computer.
Thanks.
So we've got, this is our weird piece of sodium there. Or sorry, potassium there.
Potassium, right?
Potassium, yep. I'm going to try to open this up so you can see what it looks like inside.
Oh, gosh, that cuts so easy.
I don't even need that to cut. It actually opens up really well.
Wow.
Can you guys, this is not really easy to see, but it's very shiny inside.
I see it.
Yeah, so it's a bright, shiny inside, but it gets dull really fast.
Oh, it is. Huh. All right, well, potassium is in the same family. It's even below sodium in the family of the alkali metals. So what do we think is going to happen? Do we think that it's going to react more or less than the sodium? Well, I guess we'll find out, right, Mr. Man? Because you're going to throw that chunk of lithium or of potassium into our beaker, right?
All right, here we go. Trying to use a similar sized chunk, same amount of water. Whoa!
Woo!
Fire! Fire!
Look at that! Nice! Look at all that vapor. We obviously had a burst of purple flames.
And so again, I didn't want to read all the warnings to you on this one, but it does say, extremely dangerous in contact with moisture and water, releases hydrogen with sufficient heat to cause ignition or explosion. So all the vapor is actually hydrogen coming off. May ignite spontaneously in air or oxygen, can cause severe skin or eye burns. Again, shipped under oil. And then I've got like pink on my fingers from the previous stuff, but let's see if I can see if this turns pink.
Look at that. That's great.
All right, so that's from all this smoke we generated. And I put some of this in there and...
Bingo.
Oops, got a little lower.
Oh, sorry.
And there we get our pink color, just like we had before. So similarities, but differences as well. So same family, same types of reaction, but then we also, in this case, are getting much faster reaction as we move down. So that's the end of the ones that we are going to do in the alkali metal family. There are a couple more that are there, but you get down to francium, it's actually radioactive. There's not very much of that. And then rubidium and cesium are just very rare and hard to find as well. So we don't have any of that. But I'm sure you could predict what would happen as you keep on going down. It could become more and more reactive as you move down the chart. All right, so now we're going to transition from there to looking at a period trend for the metals.
That's right. All right, guys. So now on your sheet, we are looking at the row or the period of elements. So across the row, we've got potassium all the way on the left. And then next to it, we have calcium. And I think I put a picture of milk or a milk carton for calcium and a banana for potassium because bananas have a lot of potassium in them. And then for copper, I put a picture of a penny. So all of these elements are found in the same period. And we're going to investigate how the reactivity of metals changes across a period from left to right. And we've already looked at potassium, right? You should already have some of those observations already written down. But now what we're going to look at is what happens with calcium and copper when we put those things in water. So we're going to start, there you guys are. So we're going to start, potassium we already did, so we already know what that does, right? The burst of purple flame. But the next element that we have in the row is calcium. And you guys know what calcium is, right? It's a mineral. You get it from dairy products. You get it from spinach, from leafy greens. But what does it really look like in its elemental state?
Oh, that's not oily like the other ones.
Not at all. Here we go. That is calcium. It just looks like little stones. So the hazards are contact with water releases a flammable gas. So let's see what happens. So this is calcium. This is what you need in your bodies in order to contract your muscles, in order to conduct nervous impulses. So let's see what happens when I put this alkaline earth metal into my water. Oh, but first, I want to show you something. We're going to put this phenolphthalein into the water.
Oh, yeah, that's good.
Let's do that first.
Because remember before what happened? It turned pink, right?
It sure did.
And she's adding nothing's happening.
No, nothing's happening. That's because all I've gotten here is pure water. But watch what happens when I add some calcium.
All right, so one thing you should notice right away is, did all the other ones sink or float?
Oh, yeah, they floated.
Yeah, and now this is now sinking. Whoa, look at that. That changed colors right away, and you guys might be able to see
Down a little bit.
bubbles.
Oh.
See all those bubbles? Oh, yeah, so it's bubbling like crazy.
It sure is. And wow, it's warm. Oh, that feels nice on my hands. My hands are always cold.
Boy, I could use some strawberry milk right now.
Well, don't drink that, Mr. Mick.
Oh, yeah, okay.
That's not part of our lab contract.
Yeah, it looks good, though.
Uh-huh. Now, so calcium, oh, that feels so good. So calcium is in the same period as potassium, but it's not in the same family. And did the calcium burst into flame?
Nope.
No, it didn't. So think about what's happening as you go across this period. So you had potassium, which burst into flame, and you had calcium, which, I don't know, what do you think?
It's a pretty nice reaction.
Yeah, pretty nice reaction, but, no fire, no explosion. I know you all are very disappointed about that. But that's what happened with our calcium. But also, it turned pink, just like all of the other beakers that we use. They're all lined up right over here. So just like the other metals, calcium reacted with the water to produce a base, to produce something new. And that's what turned the phenolphthalein pink. Remember, the phenolphthalein was clear when it was in just the water alone. Whoops. Okay, now we're going to look at our last element, and we're going to look at copper. So copper, as you know, makes up, Copper, as you know, makes up the outside of pennies. So that's why we put a penny on that sheet that you guys have. And, ooh, how do I do that? There you go.
So a lot of times people would tell me that kind of looks like, you know, shiny nail polish or whatever.
Oh yeah, for sure.
But it's definitely really pretty.
So let's see what happens. Now look at potassium had a really big reaction, and then calcium had a reaction that was a little bit smaller. Think in your mind, what do you think is going to happen with the copper? Is it going to have a bigger reaction than calcium or a smaller reaction than calcium? So let's put our phenolphthalein in here again.
So again, no color change right away.
All right. And now let's add our copper.
All right, so it went right to the bottom.
It did.
And waiting for something to happen.
Still waiting.
Now, if you guys think about this a little bit, if you were walking around with pennies in your pocket on a rainy day, would there be a reaction? What do you think would be happening? Would you get like, you know, fizzing going on and gases being released and fire happening? That wouldn't be a very good thing to have if you're carrying pennies in your pocket.
Nope, it wouldn't. I thought maybe I could speed something up if I just stirred it, but
nothing is happening.
Nope.
All right.
All right.
So what does that tell us?
Well, I think it tells us, Mr. Van, that as you go across a period, the reactivity of the metals goes down. So you're going to get the most exciting reactions on the left of the period, and they get progressively less exciting as you move to the right.
And then the ones I did, from the top to the bottom, it became more reactive, right?
Yeah, exactly.
And that should agree with the trends that we learned the previous week.
That is correct. All right, everyone. We hope that you enjoyed this video. We had fun making it for you, and we'll talk to you in class.